All right, let's start with talking about the green walls in nature. Um, how should tall building designers incorporate nature into high rises? Green walls, sky gardens, these sorts of things. Do you see them as a positive trend?
Um, I do see a lot of the atrium spaces coming back. A lot of the lecturers at the conference talked about those. I mean, I think it's a very interesting concept. Natural ventilation is so critical, I think, for a lot of inhabitants. You know, regardless of the green aspect. And then these atrium spaces, in a lot of cases, contribute towards green vegetation and things. I'm a little suspicious sometimes of the green technology in climates where it's not going to be conducive. In Chicago, we have had some growing pains with a lot of our green roofs. If it isn't, you know, the correct types of plants, it ends up not working, and it ends up using up more energy, and it's somewhat of an eyesore as compared to, you know, really what it's trying to do. So I think as an industry, just like the green roof industry has really prospered, and there's some very successful green roof systems, but there were some growing pains. Growing pains is kind of a funny way of thinking about it, but
Sure.
yeah. So I think with time, I do see it as a possibility, but I think getting the right sedums, getting the right environment, getting the right plant life is critical. Otherwise, it just looks like a disaster.
Execution.
Right.
If you could select a major tall building design, construction, operation, or management topic that needed more research right now, what would it be and why?
The interesting thing is you know, we've been building tall buildings for a long time, and currently we're placing them in climates that we haven't in the past. And I think a lot of architects are using the same tools, the same kits of parts, thinking they can take those same materials and transport them to different regions of the world. And you know, a skyscraper that's designed for New York isn't going to necessarily be the right materials for a skyscraper in the Middle East. So carefully, I think all of us are working hard. That's what the conference is really about, sharing different things that have gone well and things that haven't gone well for some of these projects. I think focusing on the various climates where we're building these buildings is something that the council's very interested in doing, regardless of the size of the building. I think it's very important that we get the right materials in the right climates for the best performance of the buildings.
What qualifies as a vertical community in your mind?
Well, as you might know, I'm from Chicago, and I think about the Marina Towers. I think about Bertrand Goldberg's corn cobs, and how he had this concept where a city would be a vertical city. This isn't a new concept by any means, and you know, but if you look back at Marina Towers, there's some things that weren't successful. You know, people do want to get outside. People do, you know, the idea was, I think Bertrand Goldberg, I mean, they had a supermarket, a dry cleaner, a theater, a bowling alley. They were all within the same building. And, you know, you go there today and some of those things aren't successful. You know, people do want to go out. They don't want to necessarily shop in the same building where they live. And anyway, I think it's, that's one of my favorite vertical, you know, concepts, and you know, it's from a long time ago. So I'm sure there's a lot of other people then talking about how, you know, there really aren't new things out there. This is kind of an old concept, but it's a great concept.
Do you think there's anything to the argument that the increasingly tight engineering being applied to tall buildings is causing or contributing to hazardous conditions like falling glass and ice?
I don't necessarily think it is. I'm only laughing. I'm thinking about something else. All industries are faced with this dilemma. Any industry that's moving towards things. A good example is the automotive industry. If you look at the invention of the car, it actually parallels the skyscraper. And if you think about today, you know, are our cars safer? Are they more energy efficient? You know, are they more appealing than at the 19th century? You know, well, of course they are. You know, and at the same time, would it be strange for anyone to think that a car manufacturer wouldn't have a recall? You know, that certain problems wouldn't occur. They're going to occur for engineers of those types of things the same way they're going to occur for the architects and the building engineers today. We have to expect there's going to be problems, and we have to expect that there's going to be some recalls. And, you know, we're not going to go back to a horse and buggy. You know, we're not going to go back to buildings that are, you know, less than 10 stories tall because of potential problems.
But do you think tight engineering facades has created any new problems or made it more difficult to deal with such problems?
No, I don't think, and when you say tight, you know, it's interesting. Initially, I was thinking tight. I thought you were talking structurally, but I think maybe what you're talking about is
insulation.
Right, the lack of air infiltration. Yeah. No, I mean, I really don't. I honestly, I was thinking more, you know, when you talk about glass breakage, I think of structural. I didn't think that's the thing that was leading me towards that. I didn't necessarily think about it. Air tightness, quality, you know, it's interesting. I think I've worked on a lot of projects where the owner, certain factions wanted building operations. They wanted the buildings to be open. You probably know about a lot of these projects. Hotels, for example.
Yeah.
Well, it wreaks havoc on the building because the average user opens the windows and the building, you know, it can't control itself.
Yeah.
So as these, you know, tall buildings are trying to be managed by a group or an organization, they need to manage the controls. Having non-tight buildings, that just wreaks havoc with stack effect and other problems, cooling, heating. I mean, they can't control one of these tall buildings if at random floors anyone can open and shut windows. So I don't see that tightness as being a problem. I think it's very important that you get the vapor barrier in the right location. You have a good vapor barrier depending on the climate, like we talked about earlier. Climate's critical to figuring out what works and doesn't work for a building. But no, I don't see the tightness in the building as being a problem. It's actually what a lot of our buildings strive for. If we have a tight building, we're less likely to get air infiltration, which causes problems with the mechanical. You're far less likely to get water infiltration. Water infiltration is a real problem in tall buildings and small buildings. But it goes exponential with a tall building that isn't tight is going to be sucking in water depending upon the time of year, depending on geographically where it finds itself, summertime, wintertime. So no, I think tight buildings are good.
What does the future hold for facade design in tall buildings? Are we going to get away from shiny steel and reflective glass as the dominant paradigm or not? And why or why not?
Well, I think I was thinking about those materials. I mean, especially for tall buildings, we're looking for materials that are durable. If we find ourselves in a situation where we have a large surface area in a hard-to-access area, and we end up with a problem with one of those materials, you know, that's a bad problem to have. So I think architects, owners, engineers, they're going to strive towards using durable materials with historical precedence. I mean, glass and stainless steel, those are pretty durable products. We are constantly working with coatings and finishings, and so we're massaging those. But those are two very good products. I think but you know, if you even consider the history of the skyscrapers, a little over 100 years, I'm sure we'll find other materials. But even when you talk about, you know, metals, I mean, there's stainless steel, aluminum, zinc, titanium. There's loads of different metals. Metals are a very good solution. How we coat them, how we finish them, I think is where we're going to be striving in the future. I don't see us putting wood on the tops of our tall buildings. I think there's limitations with concrete, and there's limitations with plastics and rubbers. There's a lot of limitations with those. But I think the architectural and engineering community is really working hard to strive towards understanding those materials and, you know, really making them better. I mean, that's really a lot of what this conference is all about as well.
I guess striving for some sort of composite system that uses the strengths of each material appropriately.
Yeah, a composite system is a great example. You know, you talk about glass fiber, reinforced concrete. You talk about, you know, different aluminums and alloys. A lot of times we were talking about in a discussion earlier how zinc by itself is kind of a weak metal, but if we can include titanium in the metal, well then it gains the strength properties that we can actually use it on a facade as opposed to just a roof. So a lot of it's the combinations of different materials. Just like you say, composite is a great way of putting it. And I think you know, it's going to be the same kit of parts, but we're going to just massage the materials slightly, and I think that'll be a good thing to strive for.